hyperconverged arrays and are very dedicated team. So if you could go into a presentation of that type, that would be useful, and I can share it with them, and then perhaps I can drive some questions with them. Fair?
Okay. And feel free to ask questions
Great.
along the way. So last time, I think what we did first was we covered the first 5 or 6 charts just in a PowerPoint. The rest was a demo. Do you want me to go through the PowerPoint that frames up who? Okay. So visual storage intelligence.
This is not necessarily for me alone, but for the rest of the team. All right?
Okay. Sounds good. Okay, so Visual Storage Intelligence is a product that we've been around for about since 2012 is when we came to market. This chart's a little bit old in terms of the number of things that we analyze. Let me close this window so you can see everything. What we do is we analyze, we do storage reporting and analytics. So we're not a monitoring tool. We are a SaaS-based offering, so all of our delivery back to the customer is based on through a web browser. So data is collected on a periodic basis. You, the customer, control that periodic basis. You upload your data. We parse it all up, put it in relational databases, give it back to you for business decision making. And so one of the advantages of that is, obviously, as we release new functions, and everything is available to everybody. So as we go forward and other customers may be asking for things, all things are available to all customers. In our first year of announcement of our product initial offering, we were actually a finalist for Product of the Year, and the 2 other vendors were IBM and EMC. One of those 2 products actually use us for the storage analytics when they have a one-time assessment. So it was both for IBM, which is a product called VSI, and Dell was a product. It was basically the product Quest, which was the performance analysis tool that was purchased and then bundled as a separate name. Quest actually used us for their own performance analysis when they struggled with something, and IBM VSI offering was a rebundling of existing things. But we really do different, fundamentally different things. We looked at the market early on, and what we discovered was there's 2 kinds of tools. One is the real-time monitoring alerting tool that every vendor has. These are typically high-end tools that monitor everything on a moment-to-moment basis that you would use to drill in and find a particular operational issue right down to the LUN, hyper, whatever it happens to be. These tools are typically in the millions of dollars, fairly expensive, and usually require at least one person dedicated just to maintaining the tool itself outside of the storage arrays. In most cases, they're vendor specific. They may have, IBM might support other vendors, but not typically a broad range, and typically not with the same depth that they support their own products. And the other probably most popular product by a significant margin, like over 90% of customers we encountered were still doing manual spreadsheet processing for reporting and analytics, even if they had the monitoring tools. So our goal was to set out, and we said, listen, the arrays have all the data. When a customer opens an incident with a vendor, they send that same data up to the vendor in their support, upload your support data. We're just going to repurpose that data and turn it back over to the customer by putting it in relational tables so that then our imagination's our limitation. So we not only do reporting and analytics on configuration data, performance data. Once we have the data in a database, we can do trends over time. So you can predict the future. You can get forecasting information. We allow for showbacks, chargebacks, so you can have $1 per assigned to arrays and assigned to specific storage groups, and track who's using what to make sure the right resources are being used by the right people. These are enabling the storage management process for us is that the typical users are not the storage admin people, but they might be a significant benefactor. In their case, many times in organizations, the management team will come and ask for something that requires the storage management team to then go to individual arrays, collect some data, build a spreadsheet, build whatever it happens to be. It might be a custom script, which if it is the case, then it's typically maintained by an individual, and if that individual walks away, then the script's ability to support the customer may or available. So we're doing planning and reporting across the environment, deep analytics, both at the array level. We actually provide 7 levels of reporting. You'll see that in the demonstration, all the way from a business function down to the host LUN detail and a series of layers in between. So 2 of the layers are customer configurable, where you can choose how you want to group your business units and your applications. And the rest of the layers come from the array itself, all the way from an enterprise level, a data center level, a host level, a LUN level. So that's the kind of analysis that we do across the environment. And we're really trying to enable single pane of glass reporting for storage and a single version of the truth. That's why this circular chart of the planning process, analysis process, reporting process, and everybody's using the same information rather than each individual maintaining their own piece of information. What we do, this is really this, and the next chart will be the last 2 charts I'll show. This just shows what we do. We are non-intrusive. We don't require anything to be installed at the customer site. From a SaaS reporting perspective, we ask for a virtual machine primarily to say how often do you the customer control, how often do you want to run the data collection scripts, and then how often do you want to FTP the data to Visual Storage Intelligence. So there's nothing to install. The scripts are all standard command line interface scripts that every vendor has their standard. We use those standard command lines, primarily because we get the most depth of analysis from that. If the array doesn't support command line, we will do an at-rest API if that's the only way to do it. We collect the data, process it all online. All of the data processing happens in the cloud, and all the reports are delivered in the cloud. And then the analysis that we perform, this is really one chart that says everything we do. At the far left, top left-hand side storage shelf, it's an individual array analysis. So we analyze the array, what we call from the inside out, the outside in, to make sure everything is configured properly. If not configured properly, we have categories of red light, green lights, and we show you here's a red light condition and what the condition is. So all the way from this weekend, we had a customer install some new arrays, and we pointed out to them these arrays, while functioning, have our reporting shelf errors so that one of the failing parts had failed over to another part, so the customer could go get that resolved quickly before the takeover part had any issues. And we give it to you at the enterprise level, so you can have different vendor products all installed. We'll summarize for you up to the enterprise level what and how storage is being used, where free space is available, where you've over-provisioned, and those kinds of things. Deep performance analysis and business unit reporting. Our performance analysis, we track 4 things across all arrays: latency, IOPS, megabytes per second, and node utilization. So those 4 metrics are, in some cases, node utilization might not be provided. Some arrays just track the top 3, but those are the 4 things we track over time so you can see. And we track it at all levels, from the array itself down to the individual pool, if there are multiple pools in an array, to the node, and then to the host and LUN. So we can actually see what is the host performance all the way up to what's the array performance. And we actually then integrate that into our business unit reporting. So we show you what your business unit, who's using what kind of storage, and the performance that each business unit is receiving. And then the bottom layer is more detailed reports for capacity planning, provision reporting, which allows us to actually group and show you what's been allocated versus what's been used, and show you some differences between free space that's been provisioned and free space that has not yet been provisioned. A flash analyzer is every single array that has performance data. A flash analysis is done and a report is posted into the account each time that array is uploaded, primarily to give people a perspective of where is the target-rich environment for a flash array, or is there specific hosts or LUNs that would benefit from an all-flash environment. Primarily in this case to enable the decisions where people don't want to move everything to a flash array, but they want to know where's my best bang for the buck, where am I doing the most I/O, where am I not getting the worst performance, and or not hitting cache at the appropriate levels. And then VMware Analytics, we collect VMware primarily for our business unit reporting, but we do collect all the data about performance analysis, or not performance analysis, about the configuration right from the virtual machine up to the physical machines and clusters, so we can report that. The online displays are all about the storage in the VMware environment, but the PDF report that is placed into the account actually includes cluster analysis, ESX host analysis, and virtual machine summary information. So with that, I will end the PowerPoint portion of this and just walk into a demo and show you this rather than have to talk to you about it. So this is a screen that when you first sign on, you would see. This is an enterprise summary screen. So it shows here, and across the top is the different versions of an enterprise that you can see. Storage by data center, the health across my entire enterprise, disk type by storage array, each one of these things, free space by storage array. And I'll walk you through a couple of examples of these, all the way to file analysis. Now, some of the unique things we've added recently are a cloud analysis. So if you have storage in the cloud, you see over here on the hierarchy side, Amazon S3. So we actually treat Amazon and any cloud storage as if it's a device and can collect from that because, again, our primary objective is single pane of glass reporting for all storage across the enterprise so you can see what your storage environment looks like. Then down here in the table, in this particular case, the grid is, each individual array that was collected for this particular period. I can see the data center, raw, allocated, free, used, and usable, and then some specifics about the array, the number of pools, which is oftentimes interesting, orphan space. So we spend a lot of time making sure we understand if something is showing up as being used on the array, but there is nothing mapped to it, no host LUN mapping, no file share, no CIF share, no NFS share, that'll show up as an orphaned array. You see here on this particular array, there's 10 terabytes of orphan space. That may or may not be known to the customer, but oftentimes orphan space is a planned event that sometimes extends longer than the planning process was intended. If you have space savings, you'll see what the space savings are from deduplication and compression, so you know what those savings are. And then if performance exists in the array, you'll see what the performance and if IOPS and latency has been returned. So you'll see some of these arrays have both pieces of data. In some cases, we don't have both pieces of data, but you can see what the performance is. So this is meant to be, at a glance, what does your enterprise look like? So you can quickly see those kinds of things. Now, across the top, you can then look at what is my storage by data center. So if I had a specific data center environment and I wanted to see, and we use this classification throughout most of our charts, in fact, all of the charts. What's used, we put free space into two buckets. One is what's provisioned and free. That means it's been allocated but not yet been used, aka thin provisioning. Unprovisioned, I have not given that space out, and over-provisioned. So you can see in these data centers, I don't have anything that's not been given out. I just have, and I'm over-provisioned in my two big data centers. PDC is production, SDC is secondary in this demo case. I can see what my health is across my environment, so I can actually go out and look and see what is the health, where's my red light, green lights, and if I want to, in all these environments, I can drill into the array itself and then go see what the health issues are. I have no hot spares on the B side of a NetApp array. That's a problem. I have multiple size drives in a drawer. That's actually means that this array is in an unsupported configuration. So all the errors and the details are provided there. Everything you can get from our reports are either you could get it as a display you see, as a PDF, or as an Excel. If I choose the PDF, I can choose which section of the analysis I'd like. And you get that at the enterprise level, the business unit level, the individual array level, and the host. So I can walk in and see in this particular case, so I didn't really want to print that, but okay. I can go see, here's an array, here's the kind of storage it has, the kind of drives it has, a little bit older array. I can see how much space. I have 35 terabytes of usable. I've allocated 20. I have free space of 23 terabytes. So in this particular case, the customer might think, I have plenty of free space to add things. Their standard unit of allocation was for particular LUNs was 4 terabytes. What they can now do is go look and see, here's the individual pools that I have in the array and where my free space is. In their particular case, they had 7 projects that all required 4 terabytes or more. And we had to tell them, you do realize that while 23 looked good at the top level, you really only have 2 places you can add 4 terabyte LUNs. The rest would require you to reconfigure. And so sometimes the devil is in, making a decision at the high level without looking at this detailed level. So we have free space fragmentation charts like this at all levels. So you just see this one at the device level. There's also one at the enterprise level, so people can quickly get a glimpse of where do I have free space, how much is it, what's my largest contiguous free space that's available on individual arrays. So this is the array report, the detail array report that shows here's how my array is configured, the kinds of drives, the storage by server. This is the summary level. In this particular case, the customer moved from VMware to a Hyper-V environment, and so all the storage moved, and these are leftover host definitions that are no longer being used. You can see the device health report, and for everything in this environment, you can go back and look at any point in time, what did my array look like? And I can go restore. We've had people use this for forensic analysis as well. When did this problem get introduced? Why wasn't I taking action on it, et cetera? We do keep track of the physical diagram as well, so you can actually see right down to the drive level. You can get a picture of what does this array look like. Here's my loops in a NetApp environment, all the way down to the detail, the drive, firmware, et cetera. And then probably the most useful part of this is not just the drive type, but in many instances, people aren't aware of do they have any empty slots, especially if the data center is remote and nobody's ever actually seen the array. As long as this data is returned to us from the vendor, most vendors provide a way to figure out how many slots are available, and we'll show you that. This is useful on making decisions. I don't have to buy drawers themselves. I can buy drives to fit in. Then performance and history, so I can see the history of this particular array over time, its space usage. You can see my capacity has remained fairly constant. My allocation has actually gone down over time, and my usage has gone down as well. Well, my free space has gone up in the last 6 months. So you can see those trends at all levels, at the array level, at the pool level, at the host level. So that's the array level analysis. And we can get this data so we have run in the past the Fujitsu analytics. So we do know there's a way to collect the data. We had not processed this into the online, but it would take us about 2 weeks to add new devices. Most of that time is spent making sure the data collection script is as complete as it can be. And it was also mentioned if you're doing things like converged and hyper-converged, that data is available from all those arrays as well. It's just built into we can get the data from a VMware environment if it's VMware that's on the hyper-converged, or we get it from the host itself, from the actual physical host. So that's the array-specific analysis. I'll show you the hosts in a minute. I will go back to the enterprise summary just to show you across the top. So you can see, what does my array look like at a device level? What kind of storage do I have? Here's a 3-PAR with SSD, free space. Here's a NetApp array, a data domain, a whole series of things on this particular chart. And you can also look at, and that's just the array. This is the free space at the enterprise level. So I see every single array, and I see how much free space do I have on the array. So while at the enterprise level I might look like I have a lot, I might not have as much as I think. And if you click here, we show you what the largest contiguous free space is on the array and versus the overall. So in this particular case, it looked like this large NetApp has a lot of free space, but its actual largest contiguous space is quite a bit smaller than, what the, I missed. Quite a bit smaller than what's available on in the SVC environment in this particular case. You can see trends over time. So the trends over time are just that, the exact same chart you just saw at the array level for the free, used, allocated capacity, the overall capacity. Because this is a demo account, that's why there's ups and downs. Is not all the arrays have been loaded for every single day. And we also track orphan space over time as well. So that's the enterprise summary. Across your enterprise, what does it look like? You saw the individual array analysis. What I did not show you was the performance analysis. So this array happens to have the most performance loaded on it. And what it is you can see we track IOPS, which is in blue. So that's how many IOs am I doing against latency. So this is the most useful chart for most of our customers, both at the array level. The same chart exists at the array level, at the pool level, at the node level. And what you can do is see here, here's the IOPS, and you notice we're also tracking how much is average latency versus compressed latency. In some cases, you might want to get rid of some of these data points just so you can see what is my trend. So you can take things on and off, you can shrink things up and down, so you can actually see the trends as you want to see them for whatever point in data, for whatever point in time that you have. In this particular case, this user was experiencing less than ideal performance. They're averaging in the 1 to 2 millisecond response time and, in the 30,000 IOPS range. Well, they wanted better than that. They installed a flash array between February 18th and March 12th. And you notice the IOPS ratio, the IOPS number stayed about the same, while the latency went from between 1.5 and 2 to under 1. So it had the change had the desired effect. They happened to have this behind a virtualization layer, so they just moved LUNs from one array to another array and saw dramatic improvement in the overall performance by using an all-flash pool. So that's at the array level. The same thing exists at the pool level. In this particular case, there's only one pool, so it's a little bit boring. It shows you what the pool performance is, which is obviously the exact same trend as we just saw. The other one we can see is at the node level. So if you had lots of nodes and reporting, a NetApp array has this, a V7000 has this, and you can take nodes on and off, so you can drill in, drill around, see all the data. What you're expecting in a node environment is you want these nodes to be as equally balanced as possible, and what you see is node 1 and node 2 seem to have the highest spikes. So actions were taken between February 18th and March 12th, and now look, all that data looks like it's hovering very close to a perfect balance. And that's what you want if you have a node environment, depending on how the node does the balancing itself and the LUNs are configured. So performance at all levels, pool, node, array, configuration data, all of it tracked over time. And then last but not least is you can go into all hosts that get data from a storage, from the storage array. I'm going to show you what the host is. And the host can be a physical host or it can be a virtual host. So this happens to be the VMs. They're a slightly different icon. You can see here's my configuration and storage. Now, in this particular case, I don't have VM performance data, but you can see here's the two VMTKs, the size, and in this case, they're black, so they're in a pool with SSD and something else. So the actual device type for that particular VMDK is unknown. I'm going to search here. So if you have this demo account has over almost 1,000 hosts. And so I get lost in finding all the hosts. So I can look for a host called OLTP, and I can now see what is the performance of that host on May 22nd, the read I/O, the write I/O, and the latency for individual LUNs mapped to that host, and I can see what the trends are over time. So as you can see, this particular host was the one being monitored. I/O for that host was in the 2 to 3,000 range, and latency was between the 1 and 2 millisecond, dropped to under 1. And so that's the value of being able to drill in, drill around, right down to the host level, the LUN level, and then all the way back up to the business unit level, which I have yet to show you. So all of that data is available. You can actually track your host history over time, so you can see what your storage usage is and what your performance is over time. So now I'll go back and summarize at the business function level. So everything up to this point in time is the data from the arrays. We also collect from SAN switches. So if you have a Brocade switch, and kind of the interesting thing about a Brocade switch is for many of our customers, probably the thing that they're most interested in, and I'll show you this briefly, is errors. So we track all the errors over time, and these numbers can be quite large. But what's interesting is what type of error am I receiving? You can obviously reset these counters in the storage array, and I can then see my error trends over time. But knowing what kind of errors that my SAN switch is receiving and which ports they're coming from is very useful, and that's all available online.
Very useful.
So last but not least is the business unit function. Everything on this line is customizable by you, the customer. So this is, I'll walk you through the options. The IT dashboard is across all of your environment. If you want to see where am I exceeding my performance thresholds, you set your performance thresholds for each array. So you set the 4 metrics I described earlier and your capacity thresholds. And the capacity is not at the array level. Oftentimes the problem is not that my array is out of capacity, it's specific pools. So these are pools that are over 80% used. And typically the way I use this is I come in here and everything here, all the tables have the same features with sorting and selecting just like I've shown. So if I wanted to, I'll do this, well here, I can select it over here. I can come in and pick if I only want a specific thing to look at. So let's just say I just want to look at a specific business function. I can pick and choose and see which arrays have the highest usable amount. 88% of a very large pool is used. Well, I might need to pay attention to that. So you can see all of that data, but this is a dashboard for a week, for that particular week. You can obviously see here, I can actually go back and choose multiple weeks if I want to. The actual way you choose it is by going over here and picking a separate date. So you can see is this particular array showing that trend over time. We do a capacity plan for you. So the capacity plan takes all the data across all your arrays. You put them into we allow 2 levels of categorization. We call it the capacity for the category is typically things like production, dev, test, whatever those happen to be. The second level is an application classification. And then we show you across all your arrays how much is used, how much is, I'll get to this blue one in a second, how much is provisioned and free, unprovisioned, what my snapshots are, and then over-provisioned. So this commitment number is actually, we found people that were downloading their data from VSI, downloading an Excel, and then building their own capacity plan by adding additional commitments that had been made at the business level but had not yet been shown at the array level. So we allow you to input, we actually will read Excel data that's in a specific format and allow you to show additional commitments that have been made, and this data will show up as both allocated and used. So now you can see what does my storage environment look like if all the commitments I've already made show up on the array. You can choose when this data comes on and off, those kinds of things, but you can quickly see what and how the arrays are being used, and we do allow that Excel input. One of our larger customers actually used this particular chart, and all they did was this to identify what they called runaway snapshots. So you can actually see, by taking data on and off the array, how much, in some cases, this doesn't look like very much space when all of the data is there. But if I take it off and I summarize it, this customer had over 1 petabyte of storage and snapshots because they had a runaway snapshot problem. They were able to just do what I just did, click and see the data, see the individual snapshot data, and what it was in the development team, this number was through the roof. They changed that process or changed that policy and instantly brought back over $3 million in the first year of using VSI. So all the charts have an interactive capability like I'm showing you here, the ability to turn things on and off that's useful in doing some kind of deeper analysis in particular areas. Provisioning shows you at the array level how I provisioned all of my storage and what's over provisioned, and we analyze the percent of capacity, the percent of performance each array is, and the constraint. So capacity is my constraint right here, and it's the largest of those, and it's 38%. It's green. But you see in the next one, I'm over 90% in capacity, so it's in the red. So you can see at the array level, which is what a 3-par is, a Solera is at the array level as well, but a NetApp actually has data at the individual node level, so we analyze the performance at the nodes. This happened to be a very large 10-way cluster, and in this particular case, some of the nodes are okay and some of the nodes are not, and that's the point, is to allow you to be able to see where to spend your time rather than having to go in individually, then start at the high level and drill in, drill around, and spend hours doing data collection. We're trying to do all the analysis for you so you can spend your time on resolution rather than on collection and analysis. Array reports are, if you have business units assigned, you can then decide, here's my business units, and what does it look like at the array level? Here's a NetApp, and here's the particular business units that are using storage on that particular NetApp. And then we'll show all of this data in the forecasting over here. Probably the other two most useful functions on this particular one are utilization over time, so you can see what your trends are from a performance level, and this one would show you that maybe you need to change some of your performance metrics because you're already 263% of performance. It happens to be that one very large NetApp cluster. But we allow 100% of everything on this line is customer configurable. Capacity, utilization, and then performance. So you get one level deeper. So I can see how's my development capacity versus my DR headquarters. In this particular case, these are the business units that we assign for our demo account. Now for us, most customers want to track and make sure that production has plenty of space and that development and test is up at the high utilization percent. So if we look at development here at 60%, that probably isn't high enough. We would say people are now it's out here in the 55% number. So if this was a real customer environment, most customers would take some kind of action by taking storage away from the development and moving it to production if production was in need. But it does allow you to see the trends over time at the capacity and at the performance level. And then that's a view of the past. The view of the future is if I want to go see what does my if I keep growing in the past or in the future like I have in the past, I can actually see what a forecast is at the business unit level. This happens to be by application. This happens to be by what we call category. So that's the prod, dev, test kind of thing. And then we have a utility model. So we actually have an array-based forecasting model, and the utility model allows you to forecast by the individual volumes that you've classified. And this produces a fundamentally different forecast on purpose. So you actually can see growth at volumes and hosts. So you categorize those particular things at a utility level, and it will categorize the business units and show growth over time. And then last but not least is the executive dashboard. Let me see. I think I have one here I can just show you. Show all downloads. Let's go look at my downloads folder. See if I can find a IT. So this is an example of things I've downloaded in the past. I am looking for my executive dashboard. Here's one. So here's an executive dashboard that shows a PDF report. Each one of these are individual charts in the online display. I just like the fact that this is, a quadrant chart all in one, so executives can see a couple of things. What are my growth trends over time for performance and capacity? What are my reclamation status? This is something you input. We allow customers to build this chart under your control. Your challenges and opportunities. So this is any projects that are being worked. So people can see, here's the projects being worked, what the status is. And then efficiency trend. So this is a good trend. This shows my cost, my dollar per gigabyte used, and you want this to go down, not up. This says I'm making more efficient use of my storage. So it's a measure of efficiency. Now, it does reward, obviously, if I have most of my array as free space, this efficiency won't look good. If most of my array is used, it will show better. And you want to make sure that your highest price, your SSD, your highest price drives are being used, because they will provide the most penalty if not being used. So that's an example of an executive dashboard that is right here. It's just, individually you would pick and choose each one. So that's just in a chart, and I think the PDF is actually more interesting than the online display by being able to see it all at once. So you can see from all of this, I can see what my history is. I track everything. I can see what the individual data is at the host level, and I can show you a business unit set of reports and analysis. So it's 7 levels of reporting, and in our case, that's the business category is 1, the application area is 2, then there's the enterprise and data center, that's 3 and 4, and then there is the host and the LUN level, that's 5 and 6, and then the actual array and pool, or node and pool level, technically is 8. We just put the 2 of them together. So you can see it at the component level, at the array level, all the way down to the host level, and then all the way back up to the business unit. So we're trying to be single pane of glass, and as we encounter more and more things, so one of the other new things we encountered was people doing file level analysis. So I'd like to see what data do I have and how often have I touched that data. So we allow you to analyze any file structure, and we will then, the script will analyze what type of data is this, so you can see the types of data, text, audio, visual, image, movies, audio, etc. Database, compressed. You can customize a specific set of file types and other, and you obviously want as little in other as you can get. So you can see the types of data you have and when was the last time you touched it. So in this particular case, 64% of the files being accessed in a 1.6 petabyte storage space has not been touched in over 3 years. And the primary decision being enabled with this is I can move that. Why do I have this on a spinning media of any sort? Move it to the cloud, move it to tape, move it to some place that's extremely inexpensive, because I'm obviously keeping this around for mostly archive reasons if I haven't touched it in over 3 years. And then we will plot, here, if you moved it to the cloud, what would the potential savings be by file type? So you can quickly see, here's my savings, and that's what that file level overview is here. There's my 1.6 petabytes. And in our enterprise summary, if you have file level analysis being done, we will actually summarize for you what that benefit would be. This is a different file than what I analyzed right here and showed you. This is a much smaller set of files. In fact, that is what is shown when I just clicked on right here, enterprise file level analysis. So it'll show you across the enterprise. If you had multiple shares, you can actually see by share what kind of storage is there and then when was the last time it was touched. So you might have 100 shares here, or you might have, as I have right here, 6 shares, or I can have an individual share in the hierarchy. So some of the new things we have added is file level analysis to enable cloud decisions, and cloud so you can see the total storage picture across your environment. Okay, so with that, I'm going to pause. What else? What other questions do you have? Or what did I miss?
So basically, I like what I've seen. What I will say, though, is that our team is separated into 2 types, really. So there's an operational team that will manage, storage arrays and whatnot within the data center or for clients. But there's also a team, and that's principally within my team, that will do a lot of consult. So something that is useful for going in and analyze a customer that's complaining about their storage issues, or within the context of a consultancy project. The different types of storage that they have and identify for them utilization issues or otherwise. So like I said, I like what I've seen, and I think there's a fairly good mix between operational capability as well as analytic capability. Principally, what my concern would be on analytic capability. mostly because we work on a lot of consults in this way, and of the nature of our team. So,
go ahead.
I was just going to continue to say that I'd like to see a lot of the analytic ability utilized, because I do think that you all have a pricing model that allows for instantaneous, like for example, an instant pricing for a particular customer that we can do for an analysis on it, as opposed to something that may be always continuous. So you have a pricing model that does that as well?
So our pricing model is very simple. So it is based on the raw storage that you have. It's under a petabyte, and then kind of the breakdown is we've tried 5 or 6 different ways. I'm not actually, well, I'm the CTO, one of the owners. Our VP of sales owns all that. The model is basically for the first petabyte, I believe it's $40,000 per year as a subscription. And then every petabyte thereafter is, I want to say $15,000. I don't know if that's the right number. I know that we have a group of customers that pay somewhere between $25,000 and $50,000 a year because they're obviously under a petabyte but get the value. We have another group of customers that are in the $100,000 range. And then we have another that are, I don't think we have many that are over $200,000 to $250,000 per year. And those are in the 20 to 40 petabyte kind of range. I don't think you're in that range. That gives you kind of so we do all the above. I would say most of the people, so here is an exact replica. So most of the people that use our product are more the consultant types than they are the operational types. But you actually saw, as you walk through, a lot of operational people will see this. They'll go look at the health report. They'll look at a different set of screens. And we have a way to email you the summary of those things as well. So you get an email that says, here's the 5 things that need paying attention to. That's more operational. And this IT dashboard was specifically put in for an operational team. Those are more, so it's different screens in the same environment. In the analytical space, so 2 things. One, as I did not show you, is a detailed report. This app, I'll pick one. Let me go see if I can find one that has deep performance. A PDF is produced for every single time an array is uploaded. So you can scroll down through this particular thing. It shows we had a customer who was having a particular performance problem. They actually didn't use the PDF. What they ended up using was, they said, okay, who is this customer? Customer ABC. They went over and looked at the host side like I did, saw the specific host, saw the performance of that host, got to the individual LUN. Then they went to the PDF report and saw that a particular LUN was misconfigured. And they could tell that from the PDF report. They went and changed that, and then they tracked it all online. So we do have consultants, and probably the best thing I could do if your consultants want to talk to our consultants, because we have a series of people that also use this tool to consult with customers. So Adam Earl is the head of our storage practice. He uses this all the time with customers in various levels. He's almost never asked the easy question. He's asked the hard question that either A, this data looks good at the array level, but doesn't look good underneath the covers. That was the specific situation I just described. Or the reverse. The host seemed fine, but the array itself does not seem fine, or the business function is not getting the type of storage. So we've seen things like, I don't know if you'd call this an operational advantage or a consulting advantage. We actually met with a customer, and within 3 hours, the customer said, I got to upgrade the storage array. They had a dozen or so arrays. We uploaded all their data into VSI and said, yeah, you don't need to upload anything. You have hundreds of terabytes of orphan space. And because that's hard to find and not easily reported, they instantly saved money in that area. And the other thing was turning on compression, deduplication, seeing what the potential advantages are, or seeing what you are or are not getting, are all available on these screens. It's just a matter of which array do I want to analyze, how do I want to see it, those kinds of things. I would suggest that if you want if the consultants want to do that, just have a one-on-one with Adam and let him just show you how he uses the tool with customers, and that way consultants can talk to other consultants and get, oh yeah, this is how we would do that. Now I see where the data is because he does this each and every day. Does that make sense?
Definitely does.
Yeah. So he's available. Catherine he sits right next to Catherine. You can hook that up virtually anytime your guys are available. But he walks through this. And if he can't find the data, everything is available in these PDF reports. There's probably, let's see how big these things are. I want to say there's 93 pages of PDF report. So it's not little. It shows you all the front-end, back-end I/O, all kinds of details in this report. And so we do that, and here's really why we do it. In a lot of cases, the analysis or the need for the data is a one-time thing. We produce the report, and after 90 days, these reports get stored somewhere else offline. We can put them back to online upon request. But the details, the data at the individual host, LUN, block level. So in some cases, we've seen things like block performance, like my block size was too large, and that's why performance was bad. So we changed something that fixed it. But we don't put these reports, all the data for every single LUN, for every single, well, we do put that out online. But for some of this data, 93 pages online, every single measurement would be a little exhaustive for the value. So the PDF is here. So some of this is showing people where the data exists. And once you know where it exists, like here is, a set of charts that show you things like my performance, my read-write by individual LUN. So I put all the data across all hosts together, not just, and what I care about is I want to see my top LUNs that are doing I/O getting the best performance. Some cases you see that, in some cases you do not. This has all kinds of charts in it. I'm just scrolling through so you can see all the analysis at the hourly level, at the group level, at the host performance level, right down to the individual LUN block size level. So, so all that's available. It's all online, and really every time an upload is done, this performance folder gets loaded up with data. And here's how I typically use it, because you can be a lot. You just saw I have 25 or so arrays in this demo account. I just go look for the data I care about in the array I'm looking for, because you can see each individual date for that analysis is provided. So I get your point. It can be I think your point is a fairly open-ended question about how your consultants solve problems. Adam just did this with a customer where he walked through the particular customer configuration, saw performance at a specific host level, did not change the array, changed the configuration of LUNs just by clicking through the charts I just showed you.
A lot of detail. There's a lot of detail there.
There is a lot of detail there, yes. So people often ask us, we keep all the data because we want to show trends over time and be a planning tool, but as we have gone on and on, we've added more and more operational features. We're not trying to be, here's what we're not trying to be. We're not trying to be a monitoring tool. So a monitoring tool sits on site, takes something moment to moment, but over time we have added, I would call it operational features that are of value, but we don't want to everything you're looking at here is out-of-the-box function. We don't want to have most of our customers have people that do storage things and 6 other things. They might be very large, 10 to 20 petabytes in storage, but they don't have time to maintain a separate product just to do performance and, just to do specific analysis. And so all of this is out of the box. We've added it over time, but we have not tried to be a monitoring tool, which would require us to sit on site, get all kinds of approval for that kind of stuff. And so if you're looking for a monitoring tool, that's really not who we are or who we ever intend to be. We do very deep analytics, and because we're a web-based company, we can do things on the web you can't do with on-site. So for example, some vendors don't report the speed of their drive in the array. So we actually look up by part number. For those vendors that do not, because we're web-based, we can find it on the web. Here's part number ABC. It's a 10K drive, a 15K drive. Now, why do we do that? Do we do it because it was fun, Originally, we did it really because it was a technical challenge, to be perfectly honest. But the problem we're trying to solve is the 10K, 15K problem. We walked into a customer, said, I'm experiencing bad performance. I looked at him and said, point blank, if it's on these 4 hosts, I know why. He said, how do you know why? I said, because I can tell you, those 4 hosts are served in a pool that has 10K and 15K. You just replaced a 15K drive with a 10K hot spare, and so everything has been slowed down in that pool. They had spent the last 2 weeks, and I had just met them. They had spent the last 2 weeks trying to performance and tune and check this and check that. They were all at the host level. They couldn't see the forest because they were stuck at the tree or the bark level. And so we just showed them, by the way, that's an analysis that we can do. Our health check analysis is actually 2 levels. So we have analytical engines that are general. So a general that applies to everybody. So if you name 2 distinctly different resources, a server and storage pool, the same exact name, we red flag that. You can never have 2 resources with the same name on anybody's array. Some vendor arrays, we see this all the time. It's probably most typical on an EMC array where we see it, because people have left defaults and they don't really realize they could be getting themselves in trouble. If you, the manager, walked in and said, go delete 1, 2, 3, well, if I have 3 of those, which one do I delete? And we have seen that. I have seen that in probably 50% of the VNX and Clarion cases I've analyzed have had that condition. And I've seen one customer who had experienced the case I just described. So that's our general case. And then we have best practices against each one of these things. So our VMware best practice analytical engine, it doesn't allow you to have duplicate VMDK names. It's allowed if somebody's copying things around and going outside of VMware. But my VMware consultants say if anybody ever did that at Clear Technologies, we'd fire them. So that's a red light for us. It's you're going outside of VMware. If you ever turned those same 2 VMDKs on at the same time, you'd be in trouble. So we have our own best practices engine, and the analytical engine that's best practice for NetApp is different than the one for Hitachi, is different than the one for VMAX. We did do, as we described earlier, we did do a project with Fujitsu in the USA. Eventually, right in the middle of the project, everybody changed, so we and this is now several years ago, I went and looked at the analytics and said, I think we have the basics of the script. I think we could probably put Fujitsu online fairly quickly, but I'd want to revisit as things change. Is there a better way to collect the data? Those kinds of things. But the really cool part is being able to see across all these different vendors because they all report it differently. Some people misreport certain things. And we can do, so there's some other simple things here. So in this demo account, I actually have some interesting data that not most people look at, is if I go to page 2 here, so we can tell things. This is a very real customer situation. They have a VMAX installed with almost 170 terabytes of storage. They happen to have a Pure array, and they happen to have an Extreme IO array of the same size. The Extreme IO arrays, 25 terabytes of actual raw storage, but your effective storage is 47 because all of those arrays, many of these flash arrays come with compression and deduplication turned on, so you want to be able to compute what my effective space is. The same size data for a Pure array is twice the actual effective storage. So, these vendors don't like me sometimes. They say, I'm just reporting the facts, man. This Pure array is getting 4x compression to deduplication. You're going to be able to store more data. So you can see this customer on 20 terabytes of storage, 25 terabytes of Pure storage, is actually already using 54 terabytes of space, and the projection is they could use up to 113 terabytes. So there's some other interesting things you can do here. We try to take all of those things into consideration, and to be fair, since we have a number of customers with a number of arrays, different technologies, we're learning all the time as we discover new rules to apply. We apply them, but we generally meet with all the vendors, make sure all the best practices are adhered to, and we have subject matter experts on each array type so that they can tell us, you know what, this might be allowed, but it's really a bad idea. And here's where it could get you in trouble. So I just described my VMDK. My VMware consultant I would trust my life with, and he said, man, if anybody ever does that, we should fire him. So that was reason enough for me to make it a red light. So does that make sense?
All right, so then, yeah, it does. Unfortunately, I have another meeting that I think was already started, so okay. I must depart now. But please share the recording with me so I can share it with my team.
You
I
got
have to schedule something with Catherine and with what's the gent's name you mentioned?
Adam.
Adam Earl.
Adam, right. So that we can do a consultant's dive to look at things you will do, I guess, day to day in your consultant's realm. All right?
Yep. Sounds good. Yep.
Okay, thank you.
Thanks a lot.